I might make that like way, way, way bigger. There we go. Oh, that's not it. There we go. Okay, real quick look. So what's this telling us? This is kind of the thought process you go through when you're solving a quadratic equation. So start at the top. After simplifying, is there a single instance of the variable? In other words, in the language of the class that we've used so many times, can you point to a single x? I mean, it doesn't have to be an x. It could be a t or an a or whatever. I mean, whatever the variable is, can you point to, say it's x, can you point to a single x? After you have combined like terms and everything, right? What if you can't? What do you do? If the answer is yes, isolate x, right? Just work backwards through order of operations, isolate x, and you're done. That's it. Questions? Okay. What if the answer is no? Okay, so you can't isolate a single x. Then, let's look at this. After doing the following three things, writing the equation in standard form, dividing both sides by a number if possible, and making sure that a is positive, is a greater than 1? If you're stuck, after doing all that stuff, if you're stuck with an a greater than 1, if that's the answer, is yes, what do? Quadratic formula. Don't mess with trying to factor it. Maybe you could, using bottoms up, trying to complete the square. Probably just not worth the effort in those cases, right? Just use the quadratic formula. Okay, what if a is positive after doing all that stuff? Then we ask, oh man, is that right? Let's see. Oh, if a is not greater than 1, right? If it's not greater than 1, so if a is equal to 1, then what? Well, do we have magic numbers? If a is equal to 1 and we have magic numbers that multiply to c and add to b, what do? Right. So do magic numbers exist? Yes.
Factor and use the zero product.
Yeah, we're just going to factor, and then it's simple, right? We factor and use the zero product property. Okay, so what if magic numbers do not exist? Then we just ask ourselves, oh, that's supposed to be b, not a. Darn it. Okay, scratch that out on your papers. Write that as a b. I know. Right, that should say, is b even? If b is even and a is equal to 1, what could we do? What's probably the easiest thing to do then?
Nothing but complete square.
Yeah, complete the square, right? Does that make sense? Because then it's really simple. Then it's probably even easier than quadratic formula. Could you use quadratic formula? Yeah, you could, right? I mean, it's not going to be, if you, on the test, and you'll see when you get to the Unit 5 stuff, the first assignment is just all multiple choice. What's the best method? So in that instance, if you picked quadratic formula, you'd still get 90% credit. But to get 100% credit, you'd recognize that completing the square is a little bit quicker, right? And then finally, what if magic numbers don't exist, a is equal to 1, but b is not even? Like you have x squared plus 5x plus something. Do you want to complete the square there? Like an example like this. Like what if you had something like, like this? What if you end up with something, after all the dust settles, you've simplified stuff, and you end up with x squared minus 5x plus 10 equals 0. Is that a good one to complete the square on? Think about it. If we push the 10 to the other side, what's the problem with completing the square there? Yeah, look, I'm going to end up with fractions, right? Which means I'm going to have to add a fraction here and a fraction there. Not that you can't do it, but it starts to become a little bit of a hassle. So why not, if you're going to get fractions anyway, why not just use the quadratic formula? Does that make sense? Okay. So if it's even, great, complete the square. If not, quadratic formula, right? Make sense? Okay, so I'll fix that one little mistake, darn it, and I'll update that on the site. On your papers, just scratch it out and write is B even. Okay, you may